So take a look at this diagram, but don't get too scared by it. You know, I have to put it up on the screen and I know it looks busy, but I promise you these concepts are very, very simple. So here we have two lines and we have these letters here with little dots so we can kind of like draw these little angles here and kind of reference what's going on in the diagram. So I have a diagram right here and then we have a diagram right here, okay? So let's just read the very first thing here. AEB and DEC are called vertical angles. So AEB and DEC. So what we're saying is this angle right here is vertical to this angle right here. So if I had to name it, I wouldn't call it vertical angles. I would call it X angles, because vertical angles basically are telling you that when you draw an X with two lines, the opposite angles that are right across from each other, they're always the same angle. They have the same value and they're called vertical angles. So instead of looking at that drawing, let me draw a different one over here. A couple of different examples. What we're saying is if I draw two straight lines that cross any which way, then I know that this angle right here is the same as this angle right here. So we can call it theta is equal to theta, right? These are the same. You can see this one's open wide and this one down here is also open wide. And also separate to that, these across from each other are also what we call vertical because they are equal as well. So these angles are equal as well, right? So any which way that you cross two lines like that, whatever angle they cross at, the opposite angles, we call them vertical angles and they're always equal. Really quickly, I'll draw another one. Instead of one like this, let's draw one really steep like this, something totally different. What we're basically saying is that this angle over here is vertical with this one, and we're also saying that this larger angle on this side is vertical with this one. So the black angles are equal to each other and the red angles are equal to each other. So now when you come back here and you read this, you say angle AEB, this one, and DEC, this one, are vertical angles, right? We also know that this angle is vertical with this one, as I showed you over there, but we have to draw just one definition on the board. All right, now let's take a look at the second one. We're going to talk about supplementary and complementary angles. I can simplify the drawing a lot by just telling you that supplementary angles are angles that add up to 180 degrees. Supplementary angles, they add up to 180. Complementary angles are just angles that add up to 90 degrees. 90 degrees and 180 degrees are very important angles in real life when we're building things or designing things, or they just come up a lot. 90-degree angle particularly comes up a lot. And double of a 90 degree is 180 degrees, so it's also important. So when two angles, when they add up to 180 degrees, we call them supplementary. Let's look at this. AED, this one here, AED, this one right here, and AEB, AEB. So what we're saying is this angle here and this angle here, we're saying they're supplementary. They add to 180 degrees. Why? Because this whole angle that goes from this line all the way over here is 180 degrees. Remember, 90 degrees is straight up and down. 180 is when the line kind of goes flat again. So between here and here has to be 180. And so any angles that you encounter along the way, they must add to 180, and we just have names for it. We'll call it supplementary angles. So just to draw like a different picture on the board to give you something else to look at, if I have a straight line here and I kind of like take this out at some random angle like this, what I'm saying here is that if I call this angle here, I call it theta 1, and I call this smaller angle right here theta 2. By the way, don't get scared by these Greek letters, theta. We use these Greek letters, especially theta, to represent angle. You can put X if you want to think of it as angle X or angle A or whatever, but I'm trying to get you used to seeing what you're going to see down the road. We usually use the Greek letter theta just to represent an angle. So when you see a theta, you usually know it means an angle, almost always. All right, so here we have an angle theta 1, and here we have an angle theta 2. But since we know that this angle, if we measure from here all the way to the other side of the flat line, we know it has to be 180, then we know that theta 1 plus theta 2, whatever those angle measures are, they must add up to 180, and any two angles that add up to 180 are what we call supplementary. So we know that these two angles are supplementary to each other. Now let's go back to our diagram. We said AED, and we said AEB. We said this angle and also this angle, they're supplementary. Why? Because when you measure this angle and you measure this one, they have to add up to 180 because this whole thing is 180 degrees from side to side like this. All right, finally we have complementary angles. These are angles that add up to 90. So let's take a look at this diagram. Even without reading anything, you can see that this little corner box here, this means this is a 90-degree angle right here. So you can see that if this entire angle is 90 degrees, then this one plus this angle right here, they must add up to 90 degrees. So it says right here, FIG, fig, this angle, and GIH, this angle, they must be add up to 90 degrees. And we call that complementary, right? And we can see in this particular case that we've cut this 90-degree angle exactly in half because this is 45 and this is 45. And we have a word when we cut an angle in half. We call it a bisector. Ray IG, right here, is an angle bisector of FIH. FIH, bisector means to cut it in half. Angle bisector means to cut the angle in half. So we have 4 definitions we're going to use in this lesson. The first one is just when angles are vertical. Literally look for an X anywhere with 2 lines, an X. And the opposite angles, we call them vertical angles. I would prefer to call them opposite angles. It makes more sense. Or X angles or something. The opposite angles are called vertical and they're always equal to each other. Always. All right? Then we have complementary and supplementary angles. Supplementary angles are just angles that add up to 180 degrees because the angle from side to side across a straight line is 180. So any 2 angles that we encounter along the way, they must add up to 180. We just call them supplementary. In the same way, if we have a 90-degree angle, and if 2 angles add up to 90 degrees, then we call them complementary. So complementary and supplementary are the same idea. Supplementary adds to 180, complementary adds to 90. Very simple. And then we have the idea of an angle bisector. When we cut any angle in half, not just a 90-degree angle, but any angle, if we cut it in half, we call it an angle bisector. The ray bisects the angle. Slice it in half, like cutting a cake in half. All right, now let's take a look at our first actual picture. So here we have a little more complex diagram here, but that's just so we can get some maximum usage out of the problem. What we want to do for problem number 1, I'll just kind of write the problem down below here and we'll talk about it together. I want you to take a look at angle AGH and angle AGF. And I want you to basically tell me what the relationship between these angles is. Are they complementary? Are they supplementary? Are they vertical angles? So AGH, that means this angle right here, AGH, and AGF. So we're looking at this angle right here along with AGF, this angle. So in your mind, you're looking at this angle right here and comparing it to this one. Well, they can't be vertical. Vertical angles are like X angles. They're across from each other. So it can't be vertical, right? But when we look at this angle and we look at this angle, we can see that the total angle from line to line is 180. So this angle plus this angle must add to 180. So these must be supplementary angles. There are no numbers on here, but we know that any straight line is going to have 180 degrees end to end. So these must add to 180. So these are called supplementary. Actually, I think I'm going to erase this and try to put the answer over here. So we're going to call this supplementary. Supplementary angles. All right, let's move along to number 2. All right, so what I want you to do is name a vertical angle to angle BHC. Name a vertical angle to BHC. So BHC is this one right here. What would be a vertical angle? Remember, a vertical angle is the angle in an X that's just across, and it's equal in the same value. The 2 angles are equal across the X like that. So if BHC is here, this, and that's the angle right here, this angle here across would be the vertical angle. So you could call it GHD or DHG. Either way is naming it, but this is the angle here. So angle DHG. So we'll put the answer here, angle DHG. Right? DHG would be vertical to this guy. All right, let's take a look at problem number 3. Problem number 3. I want to name 2 angles. Supplementary, I'm going to write supplementary because supplementary is a long word. I don't want to write that whole thing out. 2 angle CHD. So I want to find 2 angles that are supplementary to CHD. When you read that, you read it as 2 angles that add up to 180 degrees with it, because supplementary means it has to add to 180 degrees with CHD. Now, CHD, where is it? CHD is this angle right here. So we're kind of in your mind, mark this angle right here. What is an angle supplementary to this? Well, this angle has to be supplementary to it because that would add up to 180 degrees with it. So this angle plus this angle has to add to 180 degrees. So this is one, BHC. So I can say angle BHC. And what would be another angle? So remember CHD, this is the original angle. We already covered this one. What else could be supplementary to this? Well, if we look down here, this angle plus this angle right here also adds to 180. This adds to 180 right here. So if this is the original angle, this one has to add up to 180 degrees as well. What is this? DHG. 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 So the answers are angle BHC and DHG. Those are both supplementary, or supplemental is another way of saying it. And that means that these two angles, if you were to measure them, and then you measure CHD and you add them together, you'll get exactly 180 degrees for both of those cases. All right, let's move along to a funky looking diagram right here. And let's take a look at problem number 4. Okay, so I want you to examine the angles HNO and MNL. So HNO and MNL. And I want you to tell me, are they vertical, are they supplementary, are they complementary? Okay. HNO. So we have HNO. That's this angle where the N is right here, this one right here. And MNL, which is this angle right here. So we're looking at this angle here and this angle here. Doesn't this form an X? And these two angles are opposite to each other. So right away, you know it's a vertical angle. And you know that this angle, whatever it is, if I were to measure it with a protractor, has got to be the same as this angle here because they're across from each other and they're vertical. So they are vertical angles. Vertical angles. All right, great. Only 2 more problems. Let's take a look at problem number 5. So I want you to tell me, name an angle supplementary to the angle ION. That's easy to remember, ion, right? Ion from chemistry. So name an angle that's supplementary. What we're asking is, take a look at this angle, tell me an angle that when you add it to that equals 180 degrees. So let's find ion, which is ION, which is this angle right here, this one here. What is supplementary? What would add to this to make 180, right? So there could be other answers, okay? But I can see right here that this angle plus this one right here has to be 180 because all the way across is 180 degrees. So this one, ION, plus this one, this is going to be my answer here. So you could call it KON, or you could call it NOK, right? There are other possible answers as well. Notice this is the angle of interest, but also notice that from the drawing, if this is the angle of interest, this angle is also supplementary with it because this entire thing must be 180. So this one plus this one must be 180. So IOJ. So we can put IOJ for our answer. So angle IOJ. So IOJ is supplementary with ION, but we just said that there's another answer. This angle is supplementary to this one. So you could put KON or NOK as well. So there are multiple answers there. All right, let's take a look at our very last problem. Problem number 6. So I want you to measure the following angles. Angle JOK, angle KON, and angle ION. Now, when I say measure it, I don't want you to get a protractor out and measure it. I want to look at the drawing, and from the drawing, let's try to figure out what these angles are. So let's take a look at the first one, JOK. So here we have JOK. So here we go. We want to know what this angle is. Now notice that this angle on the other side of the line is a 90-degree angle. So this symbol means that this is 90 degrees. But this angle must be supplementary to this one. In other words, it must add to 180 because going from line to line is 180. But if this is 90 and the total thing is 180, then this one also has to be 90, even though I didn't put a symbol here. It has to be 90 because 90 plus 90 would equal 180. So this one is 90 degrees. Even though we didn't write the symbol on the drawing, that's what it is. Now let's take a look at KON. Where's KON? KON, which is this angle right here. But notice that this forms an X, and these two angles are vertical to each other. And since we know that this one is 90 degrees, even though there's no symbol here, this one also has to be 90 degrees. It has to be the same as the one across. So KON has to be 90 degrees as well. The last one is ION. So ION, this angle. But notice that these two have to be supplementary to each other. This is 180 degrees all the way across. If this is 90, then this must be another 90. So ION must also be 90. So a little bit of a weird question because they all became the same answer. But it requires us to understand from the drawing what a vertical angle is, what a supplementary angle is, and so on. All right, we actually have two more problems. Now this problem doesn't have any figure associated with it. We're just going to read it and see what it says. I'm telling you and giving you that some angle HIJ and a different angle KLM are supplementary. Now I'm also going to tell you that the measure, that's with the M, the measure of angle KLM, this angle, is 56 degrees, so you must then tell me what is the measure of that other angle. It looks like a lot of stuff, but basically it's very simple. I'm telling you that two angles are supplementary. When you learn or understand that two angles are supplementary, then that means they add up to 180. That's all it means. So now that if I give you one of the measures of one of those angles, you can find the other one by subtraction. That's all that's really going on. So let's make sure we really understand. What we're basically saying here is that the measure of angle HIJ, and we add to that the measure of angle KLM, and that has to equal 180 degrees. That's what that means. When you say two things are supplementary, all you do is you take the angles and you add them together, and it's 180. Now the M just means the measure of angle this and the measure of angle that. You don't need a figure to know that when you add them together, they have to be 180. Now, separate from that, I'm also telling you that the measure of KLM, this angle, is 56 degrees. So I don't know this one, measure of angle HIJ. I don't know that one, but I know that when I add this one to it, I'm adding 56 degrees to that, and then it's going to be equal to 180. All right, that's what's going to happen there. So then how do you solve this? Notice that this forms a little equation. I mean, you know that you have to subtract, but we're getting also practice with algebra. We have some variable, but it's a long-winded looking variable. Variables can be anything. This is just a measure of some angle. Plus something is 180. How do we get rid of it? We subtract 56 from both sides. So the measure of angle HIJ has got to be equal to 180 minus 56. Because if I subtract 56 from the left, it disappears, so it's gone. And if I subtract, 56. If I subtract 56 from the right, I've kind of moved it from the left to the right. There. So the measure of angle HIJ is 180 minus 56, which is 124 degrees. Right? So this is the final answer. And if you take 124 degrees and stick it back in here, then what you're going to say is that 124 degrees plus 56, what would you get? Well, the 6 would be 130, and then the 130 plus the 50 would be 180, so that's the angle that works. So in your mind, I mean, all you have to do if you know that they're supplementary is you take 180 minus the angle, and that has to be what's left over. I write it kind of as an equation here to also get you practice with solving equations. So some unknown angle plus 56 is this. Subtract 56 from both sides so it disappears. Now we do the subtraction. We get 124 degrees for our answer. All right, here's our very last problem. We have the same situation except we have two angles here given that are complementary. And I give you the measure of one of those angles and you have to find the other. But remember, complementary means they add up to 90 degrees. That's all that is. So you could kind of say here that the measure of angle ABC plus the measure of angle DEF, right? It has to equal what? 90 degrees, right? But I've given you ABC angle. It's 63 degrees. So we'll put 63 plus the measure of angle DEF, and that's equal to 90. Now, how do I solve for this angle? This is what I want. I have to subtract 63 because this is like a positive 63. But once I subtract it from the left, it disappears. And so all I have left is the measure of angle DEF. And on the right, I still have to take this 90 minus 63. 90 minus 63. So the measure of angle DEF is going to be 27 degrees. And that's the final answer, 27 degrees. Check it by putting it back in here. 63 plus 27. The 63 plus the 7 will be 70. And then that 70 plus 20 more will be 90. And so that is the correct angle that goes in there. So again, you could just take 90 minus the angle and get the answer. But I'm trying to write it kind of in equation form so we can kind of get a little practice with real life situation when you might have to write an equation down. So in this lesson, we started out by what is a vertical angle? What is a complementary and supplementary pair of angles? And also, what is an angle bisector? And then we had a bunch of figures. We tried to identify, various questions about the angles and complementary and supplementary. And then we used the mathematical definition. When we have angles that are complementary, they add up to 90 degrees. So you can always find the other angle by subtraction. That's basically it there. And then when we have two angles, whatever they are, that are supplementary, that means they add up to 180 degrees. So if you know one of the angles, you can again find the answer by subtraction. I'd like you to go through this, make sure you understand the definitions, make sure you understand what these are and how to calculate, if I ask you to calculate with numbers. And then follow me on to part 2. We're going to do a few more problems and wrap up the concepts associated with complementary, supplementary, and vertical angles. Learn anything at mathandscience.com.